Now we will discover queues, hash tables, and tree data structures. We will then cover recursion. In this video, we will work with queues. Queues are a data structure that follows the FIFO ordering principle, which stands for first in, first out. The first inserted item is the first to be removed. Let's think of a line of people in a supermarket. The first person who joins the line is the first to leave the line. Here is a queue of restaurant orders. The beginning of the queue is called the head, and the end is called the tail. In queues as in stacks, we can only insert data at the end of the queue. This operation is called Enqueue. However, contrary to stacks, we can only remove data from the head. This operation is called Dequeue. There are other kinds of queues, doubly-ended, circular, and priority, but we won't study them. Queues have many applications like storing printing tasks in a printer. Documents are printed in the order they are received. Queues can also be implemented in applications where the order of user requests matters, like applications that sell tickets to a concert or offer taxi services. Queues can be implemented using singly linked lists. To do this, we will use the familiar node class. We will also define the queue class, setting the head and tail to none. Let's implement the Enqueue method for the queue class. First, we create the new node, and then check if the queue is empty. If it is, both the head and tail will point to the new node. If the queue is not empty, the tail's next pointer will point to the new node. Finally, the tail will point to the new node. Let's implement the Dequeue method to remove an element from a queue. In this case, we only act if the queue has elements. We create the current node variable that points to the node we want to remove, the node at the head. Then, we move the head to the current node's next node. Finally, we set current node.next to none. At this point, we need to check if our queue had one element at the beginning. If it did, we will be in the situation shown, with the head pointing to none and the tail pointing to the node we want to remove. In this case, we will need to set the tail to none. In Python, the queue module offers the queue and simple queue classes, which allow working with queues. We will focus on simple queue, which offers fewer features than the queue class, but is enough for the scope of this course. Let's import the queue module and create a new simple queue. We can add elements using the put method, get the size of the queue using queueSize, remove elements using get, which also returns the removed element, and check if the queue is empty, among other functionalities. Let's